So in this video we're going to look at how to work out the shapes of quite complex molecules, so things that have positive and negative charges and also things that have double bonds. So if you follow these steps, these are the first sort of basic steps, and we're going to go on and look at the more complex steps. It should work for pretty much all molecules or molecular ions. These steps are a little bit long-winded, so what you can do is once you're sort of comfortable with the steps, I'm sure you'll be able to work out shortcuts. So these first ones, methane, this one, these should be pretty straightforward. We're going to try this one, which requires this more sort of complex steps. Zenon tetrafluoride. So the first step is to work out the number of valence electrons. So xenon is in group 8, so it has 8 valence electrons. Fluorine is in group 7, so it has 7 valence electrons. There's 4 fluorines, so we times that by 4. So that's 7 times 4, which is 28, plus 8. So that's 36 valence electrons. The next step is to write down the central element, so xenon in this case, and write down the other elements around it. If you just place the other elements so that they're as far apart from each other as possible, you may have to change this because this is going to work out whether there's any lone pairs or not. So you may have to change. This is not your final shape, this is just sort of the working out. What you're going to do then, so the second step, is you're going to write in the bonds. You're going to show covalent bonds, and you're going to show them by pairs of electrons. So just do a covalent bond with a pair of electrons to each, from the xenon to each of the fluorines. So we've got the bonding electrons. So if you count up all the bonding electrons, we've got 8 electrons so far. So the next step is to add the electrons around the outer elements. So we're not going to touch xenon, we're just going to do fluorine. We're going to count as we go. So we've already added 8, so the next one is 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So that is 32. Right, we had 36 valence electrons. We've used 32. So we've got 4 extra electrons. So in blue, I'm going to add those onto the central atom. So any extra electrons you add onto the central atom. It's just a case of working out how many bonding pairs you've got and how many lone pairs you've got. So we've got 1, 2, 3, 4 bonding pairs. So 4 bonding pairs. And we've got 1, 2 lone pairs. So in total, that is 6 electron pairs. So anything with 6 electron pairs is based on the octahedral shape. This is the bit where you just need to be able to memorize. So you need to know anything with 6 electron pairs, octahedral shape. If it's got 4 bonding pairs and 2 lone pairs, you just need to be able to know that is the square planar shape. And you need to know how to draw it. So this is how you draw it. So we have the central xenon. For square planar, the lone pairs exist above and below. And then we've got 2 of the fluorines coming out of the screen. I use this filled-in triangle. And we've got 2 of the fluorines going into the screen, so I use a dotted line. Okay, bond angles. So bond angles for square planar, again, this is just something you just memorize. For octahedral, it's 90. That's with 6 bonding pairs. If you have 1 lone pair, so the square pyramidal, it becomes less than 90. But when you have 2 lone pairs, because we've got these lone pairs on either side, what it does is that they cancel each other out, so actually the angle is 90 again. So the bonding angle between these fluorines is just 90 degrees. And this is square planar. So it's a square shape in one plane. So it's flat. Square planar. So this thing we just did, there were other methods for doing this, and they're probably quicker methods, but the reason this method I'm showing you is good is because it allows you to deal with things with double bonds, and also things with charges, and it works with all of them. So now we're going to try one with a double bond and a charge. So we're going to do the molecule, the sulfate molecule. So the sulfate molecule is SO4 2-. So if you want to try sort of more basic method, you can try that, but it won't work for this one. What you do is you follow the steps I said in the previous one, so work out the valence electrons. So sulfur is in group 6, plus oxygen is also in group 6, so 6 times 4. Plus you've got a charge of +2, so you need to add that. A -2 charge means that you've got an extra 2 electrons. Every minus charge is an extra electron. So what's that? 6 times 4 is 24, 30, so we've got 32 valence electrons. Okay, draw the sulfur surrounded by the oxygens, and then start to fill in. Do the bonding pairs first. So 1, let's get a bigger pen. 1, 2, 3, 4, 5, 6, 7, 8. Now fill out the outer electrons. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so it adds up to 32. There's no spare ones, so therefore there must be no lone pairs on the central sulfur atom. So hopefully straight away you're going to be able to spot, okay, there's 4 things around it. It's tetrahedral, 109.5 bond angles. What we're going to do now is we're going to do something called working out the formal charge, because this isn't actually the structure, it's not actually single bonds. But how do we know that? Well, you work out the formal charge and the formal charge tells you. So let's work out the formal charge for sulfur. So formal charge, the way you work it out, formal charge is this. Oops, let's get a better pen. So formal charge equals the group number minus the number of lone electrons minus the bonding electrons divided by 2. So let's have a look what we got for sulfur. So for sulfur, right, well, sulfur is in, so sulfur equals, it's got group 6 minus the lone electrons. So how many lone electrons around sulfur? Well, there's no lone electrons around sulfur, so minus 0, minus the bonding electrons. So how many bonding electrons? 1, 2, 3, 4, 5, 6, 7, 8. So it's got 8 bonding electrons over 2, because you have to divide it by 2. So put that 6 minus 8 divided by 2, so that comes out as plus 2. So 2 plus. That's the formal charge, and we place that formal charge on the sulfur. So 2 plus on the sulfur. Now work out the formal charges for the oxygen. So oxygen, again it's group 6. This time, if you look at one, we're just looking at one oxygen, you count the lone electrons. So remember it's lone electrons. 1, 2, 3, 4, 5, 6. 6 lone electrons. So minus 6, minus, and how many bonding electrons? Well, that's got 1, 2. So that's 2 divided by 2. So that comes out as minus 1. So these have got... Okay, right. What happens now is the sulfur, it wants to get rid of this 2 plus. It wants to get rid of that formal charge. Now, if this element was in period 2, say this was oxygen, right? Oxygen follows the octet rule, and it can only actually fit 8 electrons around it. So although it's got a formal charge and it wants to get rid of it, if it was oxygen, it wouldn't be able to, because it can only fit 8 electrons around it. Any element which is in period 3 or more, period 4, 5, 6, etc., can actually fit more than the octet rule. So because sulfur is able to, it wants to get rid of that 2 plus charge by taking electrons. So it takes electrons from the oxygen. No matter which oxygen, we're going to do it from this one down here, and it's going to take this electron here, electron in blue, right? And this electron is actually going to get moved, and it's going to get essentially given to the sulfur. Okay? So if the sulfur gains that electron, it's now going to go down to a 1, oops, pen's too big, a 1 plus charge. And because the oxygen's essentially lost that electron, it's going to go down to a neutral charge. so neutral. What happens is this electron here, it's still attached to the oxygen, but it goes and forms a covalent bond with this blue one from the sulfur now. So you get a double bond down here. We've got this double bond forming here. So sulfur's still got a 1+, so it still wants to get rid of that. So the same thing happens over here. So if I draw this electron in blue, so this is our blue electron. This electron is donated to the sulfur. So the sulfur has now got that electron. So that changes the charge and brings the charge down on the sulfur down to 0. So this has now got a, oops, I didn't have a pen. Charge on this down to 0 as well. And again, this electron for the oxygen comes down here, and again with this blue one, it forms another covalent bond. So again we have two covalent bonds here, another double covalent bond. Let's now draw this as it would look like. So let's draw this. So I'm going to draw it first in just 2 dimensions, then we'll draw the 3D one. In a sort of 2D structure. So you can see you've got these two oxygens either side with a negative charge, and a double bonded oxygen above and below. Now, when you're drawing this in 3-dimensional space, you count all the double bonds, just assume that they are single bonds. So it just forms the tetrahedral shape. So we've got this 2 double bonds here and here. You do the 2 double bonds. You've got the oxygens down here. These ones which are joined just singularly have both have a negative charge. Oops, I've drawn that on the wrong side. They've got a negative charge, and that is our structure. So the bond angle's 109.5, and it's the tetrahedral named. So using that method, have a go at doing these ones. I'm going to show you the answers in about a few seconds, so pause the video. So here's the answers to the first few. Here's the answers to the other ones. And the final 2. These are some of the ones I was showing. These are the more difficult ones. I'm probably going to make another video on some more of these ones later on. So just remember, when you're using the sort of formal charges like we did for the sulfate ion, the reason we were able to do that was because sulfur doesn't obey the octet rule. Nitrogen does obey the octet rule. So for example, in this one, right, you're going to end up with this one, which is one double bond. It wants to make 2 double bonds, but due to the fact that nitrogen can only fit 8 electrons around it, that's why it doesn't. You'll also find that with some of the other ones here, that if they are in group period 2, then they are not allowed more than 8 electrons around them. So pause the video, try these questions. So here's the answer to the first 3. Here are the answers to the other 4.